Hello, everyone, and welcome to the Department of Energy's Energy Innovator Fellows informational webinar on program design and evaluation. I'm Miles Collins with Berkeley Lab. I here have the agenda for today. So after this set of welcome slides here, we're going to be looking at program design. Steve Schiller, who's a Berkeley Lab affiliate, will be giving that presentation. And also the next two presentations on program evaluation and then benefit cost analysis for distributed energy resources. And then I will be giving the final presentation on an application of benefit cost analysis for managed electric vehicle charging. Throughout this presentation, throughout this informational webinar, please feel free to enter your questions in the chat box at any time, or you can raise your hand to ask a question live, and we'll call on you to unmute yourself. We will also be having a question and answer at the end of each of these segments where you can go back through the presentation and ask any question that has come up throughout the time. Presenters today, here's some information about them and some background. Steve Schiller is an affiliate with the Energy Markets and Policy Department of Berkeley Lab. He has decades of experience in the energy industry with a focus on distributed energy resources and climate change mitigation. Steve has overseen the development and administration of energy programs in over a dozen states and in other countries for utilities, local, state, and federal government agencies and organizations such as the World Bank. He is a recognized evaluation, measurement, and verification and benefit cost analysis expert, having been responsible for many of the guidelines and protocols used in the industry. For myself, I'm an energy researcher in Berkeley Lab's Energy Markets and Policy Department as well. My research is mainly on resilience planning, evaluation, and benefit cost analysis for innovative utility programs. My experience is within both energy policy strategy and analytics, and then also within the utility industry. So I served as the Energy Services and Utility Rates Manager at Burbank Water and Power previously, as well as a principal consultant at Nexent, which is now Resource Innovations, and then manager of customer service business planning at Southern California Edison. My educational background is policy analysis. I have a PhD from the Rand Grad School and then a Master of Public Policy from UCLA. An upcoming webinar that may be of interest and registration is now open for is on data centers, load forecasting and rate designs. This will be on August 14th from 2 to 4:30 p.m. Eastern. So we'll give an overview of data centers and their growth, and look at a snapshot of Berkeley Lab's recent report to Congress on data energy center use, looking at historical consumption and scenarios for a range of futures to 2028. The registration link is here. And the presenters will be Dr. Sarah Smith and Natalie Mimsfrick from Berkeley Lab. And finally, this slide has links to resources from prior informational webinars. If you go to the link here and look under the National Trainings and Presentations and the Accordion tab, you'll see these recordings and slides from the previous informational webinars throughout the past year. And I will be posting that link in the chat in just a moment. And with that, I'm going to hand it over to Steve Schiller to get into program design.
All right. Thank you, Miles. And I'm going to bring up my, here we go. I hope you can all see that. And I need to make it way bigger in my screen, which all of a sudden it's now not doing. There we go. Hit the presentation button. Okay, so see that okay?
We can see that fine. Yep.
Okay, great. Well, welcome everybody. Glad you all could join. And as Miles said, I'm going to start off with a discussion about program design for distributed energy resource programs. As Miles indicated, if you have some questions or such, please use the chat box. We do have a lot of material to cover. We've got 4 segments that we're going to go through here on design of programs, evaluation of programs, benefit cost analysis of programs, and then a case study that Miles is going to go through. And we're going to do that all in 2.5 hours with maybe a short break in here. So if you do have questions, great. We've set aside some time at the end of each of the segments to answer them, which is probably the preferred way. But if you have something burning question, put it in the chat or raise your hands, and we'll try to get to it in real time. I'm looking at, the topics that we're covering, that if you're in the midst of doing this kind of work, this will hopefully give you some new insights and thoughts that will be beneficial as you go through your work around planning or running, implementing, evaluating, doing the analysis of your programs. And if you're brand new to this, we're probably not going to be able to get you to be an expert in 2.5 hours, but hopefully give you some good questions to ask, thoughts to think about as you put together a portfolio in your roles with these types of programs. So with that, let's get started. I thought I would start off with just, since we're talking about distributed energy resources, a quick definition here. And um, what we look at with DERs is really primarily it's some sort of energy asset that's sited close to the energy consumer. Sometimes they're considered behind the meter, BTM, but not necessarily. So these DERs can provide, some of the host facilities, energy needs, whether that's through efficiency or generation or storage, et cetera. And also it can support the utility system by reducing demand or providing energy capacity, ancillary services. As you know, common examples are efficiency and demand response, distributed generation, storage, electric vehicles, and that'll be one of the case studies or the case study that Miles will go through, as load or potential storage grid support, and then electrification. And what's been driving DER adoption, perhaps why some of you are here today, is more of a push for grid modernization, reliability, increased customer choice and options for perhaps lowering their bills, cost reductions that have been occurring in these DER technologies, and really just meeting the growing energy use and the reductions in peak demand that's being desired, by states and utilities and various customers. And at the bottom of the slide here, there's a formal definition from NARUC, the Utility Commissioner Organization. Okay, there we go. So what's the role of these DER programs? Well, what I'm going to talk about for the next about 30 minutes is to really address market barriers that prevent the DER adoption. So your programs are looked to accelerate that adoption of DERs, and trying to align the utility system benefits with the customer interest, in our modern grid, and potentially, achieving broader societal benefits that can come from DER adoption. So before I get into more of this, Miles and I thought we'd take a quick poll break here to find out where you all are at with respect to implementing these programs. So if you wouldn't mind responding to this poll here, and we can see who all we are and where we're at in these various efforts. So I see the polls are coming in. Thank you for responding there. It's like pretty balanced here. With perhaps most folks having some level of involvement or at least awareness, and others just sort of getting going on this. So looks like there's some level of involvement by most folks, but not everybody, and not that many people who are really actively involved. So hopefully this presentation and the webinar here will give you some more background to get going. Okay, so I'm going to, let's see, share results, I guess, is the, I'm going to let you work on that.
Steve, I did share them, so I just stopped sharing them, so everyone was able to see it.
Okay, excellent. All right, let's move on then. So, whoops, let's see here. Let's get back here. I'll get the right buttons going on my computer here and stop having these little messages pop up on my screen. So, why do we have these programs? Well, it's because the DER adoption is not necessarily just automatic. If it was automatic, it would just be happening. And what's happening here is that there's some fundamental barriers to resistance to the adoption by consumers. So, it's not always about money. Incentives are not always the answer. And so we implement these programs. This core idea here is that we implement programs in order to address market barriers. Programs are providing the bridges to overcome these various barriers that exist. And what are those classic barriers that exist? You'll see in my slides here, I've got a lot of words you'll find in my slides going forward. As Miles indicated, they are available starting now for you. You can download these. And again, we want to give these slides to you, and this background is some information that you can perhaps refer back to as well. So the good news is, as you see lots of words on my slides, it doesn't mean that I'm going to be reading every one of them. And let's start with this one as an example here. So classic market barriers to adoption. Just general awareness. People don't know this stuff exists. The information search cost is probably the most common question I get when people find out the field I work in is, where can I even find information about this stuff? Who can I trust? Just the hassle and the transaction cost associated with that, and the busy lives of individuals or businesses. Uncertainty. People might have doubts about how these perform. Organizational practices and customs, particularly for businesses. This can be something like a budgeting cycle that doesn't mesh with the timing of this, or just internal procedures that might hinder the investment. Split incentives is one that we see with renters, whether that's commercial or for home rentals, where the party that's paying for the DER, the owner of a building, like the landlord, does not directly receive the energy savings benefits, which go to the tenant. So you have this split incentive, which can be a key barrier. And then, of course, the one that most people think of right off is the first cost, and if there's a capital investment required. So these programs are designed to address these adoption barriers. And they're based on what's seen in this box on the right-hand side here is a program theory and a logic model to address that theory. So the program theory is, and sometimes, people get this just really as a gut, knowledge of this, but the idea is to put this into writing through your logic model as to, what you're going to do and why that's going to cause the outcome that you're expecting. And you need that theory and the logic model behind your design of your program so that you understand the basis and you can design to that and address those issues. So it's, what are you trying to achieve? What you're doing going to achieve that? And how does that work? And then you build your program design from there. So looking at DER programs, there's a range of goals and targets that can exist here. In the next couple of slides, I go through some of these. So one way to do this is by what the total goal is here. And that might be the two that I've categorized here is market transformation or resource acquisition. Market transformation, the idea here, and I have a slide later talking some more about this, is to fundamentally change how the markets are addressing these systematic barriers. So it's a change in way that the market operates. You might think about this as about ride sharing versus taxis. Something fundamentally changes in the market that changes how people perceive they get the goal they're looking for, say energy independence, lowering their energy bills, in a different way to achieve that. So you change the way the market, the common practices, or perhaps resulting in some sort of code or standard. The other is resource acquisition, and that's primarily focused on achieving, impacts immediately, such as energy savings or demand reduction, with your defined time frame by directly incentivizing the adoption. So you get these results right away, usually energy or savings. Another way to organize, to categorize these programs is by sector, the common, residential, commercial, industrial, ag, institutional. Further ways to classify can be by the target. If you're looking to reduce energy consumption or perhaps just demand or a combination of the two. And then there's ancillary services as well, such as voltage support or frequency support can be your objectives. Another way to look at these is by the time of intervention. This is a common way of organizing programs. You're looking to have a program that addresses new construction, so that you would incorporate DERs into new construction versus doing it for a retrofit program, which is looking to modify existing buildings, facilities. Another way to do this is whether you're looking to address people's decisions on investments at the time of failure of equipment when their heating system fails, or whether you're trying to induce them to do an early replacement or retrofit before a system fails. In the top right-hand corner, another point, a way of looking at organizing your programs is by the point of intervention. And what I mean by that is that who you're going to be addressing with your program design. Starting with the top there, upstream, that's basically targeting the manufacturers, the distributors, a smaller number of parties that you're working with, and focus the program and encouraging them to have the outcomes to manufacture certain products, to provide incentives, to work for the organization, working in ways with them. Then midstream is targeting the retailers, your Home Depots, your Costco's, your, CVS stores, wherever, or contractors or the wholesalers, the folks who supply these. Basically, you can be working with training installers or offering incentives to have people stock energy efficient equipment, for example, right at the end aisles. And then downstream is that direct engagement that most of us think of with the end users, with the consumers, the customers, and this is working with the larger numbers of participants in your program potential. And then lastly, by regulation. And I'll talk a little bit about this with some examples, but using regulations, whether voluntary or mandatory, to encourage or require the adoption of DERs. So some of the program tools that can be used in the left-hand box here, the one, again, most of us think of in terms of incentives here is actual financial incentives, rebates, grants, loans, and such. But also there's other ways that you can encourage these behaviors as well. Rate design, for the economist among you, it's getting the price signal correct. So structuring the electricity rates or other energy rates to encourage specific behaviors, such as critical peak pricing. And then, of course, there's education and training, whether that's for the consumers as well as for contractors and others involved in the process, other market players. And then pilot research, development, demonstration, working with emerging technologies to prove the concepts of those. So using a heating, ventilating, and air conditioning example here on the right-hand side, an example for strategies mapped to barriers would be, hey, we've got what we've identified as the first cost barrier, so rebates. Performance uncertainty is a concern, so working to develop and promote a qualified contractor network, showing case studies that indicate that these things really do provide the benefits indicated. And information search costs, providing online tools that help consumers compare DER options. And then at hassle transaction costs, working to streamline your application processes, maybe providing a one-stop shop service that can support the DER adoption. So let's get into what we do to get these programs going. So the way I look at it is your starting point is figuring out what the opportunity is. How much is out there? How much could I actually achieve by promoting DER? And the way you do that is with something called potential studies. So that's an analysis to estimate the technical, economic, and really achievable potential for DER deployment. And what those resulting impacts would be, say, perhaps in energy or demand savings. So you're basically taking a look at the existing infrastructure, the existing market, the existing baseline energy use, where the technology is at, characterizing the market, including the customers, and doing some modeling. And those are usually done by specialized consulting firms that do this type of work. On the right-hand side of the slide here, what I show is the classic way in which DER potential is demonstrated or presented out. So the graph is showing three types: technical, economic, and achievable. The technical potential is that maximum possible, say, energy savings or impacts that the deployment could achieve if every technically feasible thing was done, irrespective of the cost or the economics of it. And the economic potential puts a screen on top of that, says, hey, let's take a look at the subset of technical potential that is cost effective. And we'll be talking about cost effectiveness in the benefit cost analysis segment today. And then the third area is achievable. And this one can involve a fair amount of hand waving, but taking a look at the portion of the economic potential that actually seems like it can be achieved giving the various aspects of the market. So now I'm going to turn to some a little more detail on some of these mechanisms I was talking about for implementing programs. So again, the first one people are most familiar with, financial incentives. This is to overcome that first cost price premium that can occur with DERs. And so you might have upfront rebates, the most common approach, but also you can have performance-based incentives, a pay-for-performance approach. This is often done with demand response programs, where if the participant in the program, a commercial building, a homeowner, if they actually reduce their demand when requested, they receive a payment. And those incentives can go to really anybody in the process. I mentioned the various, streams, in terms of, upstream, midstream, or downstream, and it can go to each of the participants who you want to incent in that stream. Next aspect, rate design. I mentioned this as one of the possibilities here, and basically getting that price signal out to there. So you're essentially looking to shape behavior. You need to provide the rates that indicate, what the encouraged behavior is there by sending that price signal. Also very important is to actually provide the information people understand, what the rates are and how they affect their energy bill. For many of us, of course, reading our energy bills can be difficult. So not just getting the rates there, providing the education associated with that. And that leads to really the next category that I have listed here of education and technical assistance. And this is providing, guidance and resources, materials, and that can be for the consumers, but also for the workforce training programs. And that's really to provide the knowledge and the support and the resources for making these adoption decisions. I talked a little bit before about market transformation as one of the mechanisms that exist out there. Again, looking at the purpose of this is to remove those structural barriers, in the long term, so you can have the growth and market share that you want. And on the right there is the classic S curve, although this particular one doesn't have that much of an S shape to it. But basically, what the black line here, the lower line, is what the baseline market adoption over time would be of a particular DER technology or practice that you're trying to get. And then with the program, you're trying to get, that additional orange line there to basically speed up and accelerate and increase, the market transformation units. And so you can target a wide range of actors again in this type of intervention. And classic examples of this are efficient lighting, refrigerators, heat pumps, thermostats, where it's not just providing dollars to get people to change right now, but it's providing a long-term impact is the goal here. Another area, as I mentioned, was pilot programs and RD&D. And here again, the idea is to provide information and support that can, enable you to do long-term the kinds of programs and build both the data and the support that these things are actually working. There's some other strategies that can support DER adoption. I mentioned a couple of them here in this slide. There is benchmarking. And the idea there is to have, and it's primarily associated with buildings, but it can be done with facilities as well, is to sort of compare the energy use of various buildings with the common typical building energy use. And then that type of data is provided publicly. And so building owners and operators, as well as regulators, can take a look and see, how the building stock is doing and providing an indication as to what the opportunity might be for increasing if you're a below average or average building in terms of the benchmarks. And then there's building performance standards that sort of take it to the level where you actually have a minimum threshold, again, voluntary or mandatory. And of course, there's building energy codes and appliance standards that are utilized in a number of states. So let's take a quick little break here for you all, since I've been blabbing away here for a while, and see if you want to, use your chat box to sort of talk among your colleagues who are here about, what you see are the pressing barriers that your programs might be facing, and what mechanisms do you want to try to address those barriers. So I relist them here on this slide. And so, if you'd like, take a little bit of time here while I'm going through these slides and just sort of add your thoughts and what you're thinking about in terms of what you're seeing as the barriers to your programs, to your adoption of what you want to achieve, and what type of mechanisms you're thinking of trying. Maybe just get a little feedback among this group who are all involved in this to one degree or another. So we'll take a second here for you want to all get started on that. Okay, so I'm going to while you're doing that, I'm going to keep going here and talk about some of the design elements associated with these programs. I'm going to go into a quick slide on the life cycle, some key considerations for you to think about, a bottom-up approach for program design, and then get into some of the other considerations you might want to think about. Again, there's a lot of material that I'm going to be going through here. It's going to be tough to go through it all in the short time and probably even tougher to absorb it. But again, these slides are going to be are available already for you, and hopefully can provide a resource for, maybe trigger some thoughts for things for you to think about as you put together these programs. So when I talk about the program lifecycle, what I'm talking about here is this continuous cycle of where you're planning a program, you're then implementing the program, and then you're evaluating it. I'm going to talk about evaluation in the next next segment of this webinar here. And it's really a cycle, where the planning, the implementing, the evaluating, it really feeds on to each other. And it really becomes a cycle where, what you do in one program, supports your next efforts, as we all learn by doing. The ability to use the evaluation results and refine, the future in as well as our current programs. You can use that feedback, and I'll talk some more about that again in the next segment. So here's a whole bunch of key considerations for you to think about as you put together the programs. Um, what are your impacts? I mean, let's start with that. Is it when you're putting together your program, what do you really want to achieve? Define that and identifying what customer segments you want to work with. What DER measures are appropriate given those desired impacts in the customer segments. Again, getting into what are the barriers that you're going to be addressing, and then developing really those program theories and logic models that I talked about before about how you're going to address those barriers for those DER measures, for those customer segments, for the impacts that you're trying to achieve. And then conducting the outreach campaigns, how to inform and engage consumers. The messaging, as we see in so many areas of our work nowadays, is the communications can be just key to the success of these programs. So making sure that you consider this as you put together your programs, don't necessarily just put them out there expecting everyone to jump in. How are you going to do the outreach? And then monitoring the effectiveness, doing the evaluation. How do you track progress and use that to feed back and support your programs? Related to that is what I've got a slide here on a bottom-up approach, that you might want to use in terms of developing programs. Again, getting back to, what are your key goals and what are your assumptions, what tools you're going to use, what mechanisms you're going to use to address the barriers. And then, of course, coming up with the budgets and the cost-effective analysis that support that it's worth making this program, making the investments. And again, we have another segment coming up about cost-effectiveness analysis. Putting together your process flow diagrams, what are the steps that are involved in doing the program, just sort of basically, organizing that out as to, who does what, when does what, over what time frame you're going to be there. And then as you get into the programs, what are the criteria for participating in the program? How are you really looking to target? And something I'll talk a little bit more about soon here is partnership agreements, working with contractors, the term trade allies, which I'll introduce. And then again, as I mentioned in the last slide, really working through your marketing and communication strategies. So another key consideration is, of course, budgeting and looking at risk management, as well as, coming up with key performance indicators. So I have a pretty busy slide again here with some of these points. I won't again necessarily go through all this, but here for your reference, just remember that, of course, you need to do some budgeting. But the main point I want to talk about here is, having a risk management strategy. Surprisingly, shockingly, things don't always go just the way we expect. So having some strategies some milestones, some ways to look and identify when things aren't quite going as expected, and having some strategies for addressing those and making changes as you go forward. And of course, also should probably mention exit strategies, thinking about how this program, will reach its endpoint, hopefully a successful endpoint, and how, that will affect the design of your program so that you have an exit strategy. And then this adaptive management gets into, applying that risk management strategy and having those key performance indicators, those KPIs, that you can use to track the metrics, say relating to participation, or the number of people signing up as you anticipated, are you getting the volumes and impacts that you're expecting? And then, particularly for publicly funded programs, ratepayer funded programs, and, having transparency in the reporting so people can be aware of what's going on. Another key consideration, moving on from the program, nuts and bolts that I was just going through in a few of the last slides, is thinking about non-energy benefits. And the reason I wanted to put this in there is that, if you're coming at this looking at what are the system benefits for your utility system, for your grid, or just really thinking about the energy savings benefits that can drive consumers to invest in this, what we've seen within the industry and doing these for many years is that often the non-energy benefits are what drive consumers to make these decisions. And these can be a wide range of things beyond just the energy cost savings. If we look at, say, energy efficiency, can certainly improve the comfort. And you have good systems that you put in, new, efficient, well-working systems, can improve productivity, the property value, for landlords, improving their comfort value. Certainly with a number of DERs, they can provide power during outages, so reliability and resilience. Certainly some people are interested in environmental stewardship, and also just having these systems can enhance their control. So as you design your programs and think about what consumers are interested in, think about those non-energy benefits as well as the energy ones. Excuse me. As I hinted at before, another part of your program can be the trade allies. And the trade allies are those contractors, installers, the ones who actually deliver these DERs. And they provide the expertise and the installations that, meet your program requirements. Excuse me. So trade allies can be really a key to program success. And so I encourage you to think about who you're going to be working with to implement this and thinking about working with them. And again, those can be upstream, midstream, or really, supporting you directly in the downstream. For example, in the downstream is, the plumbers, the electricians, making sure that they're aware and engaged in your programs. And the last segment for this presentation here is around roles and responsibilities. Excuse me. So program roles. So here's a way in which to sort of think about the different participants in your programs. So you have that oversight authority. Perhaps many of you are involved in that, and you're responsible for establishing the program framework, setting the requirements, determining what means by compliance, really monitoring the overall performance and safeguarding, the ratepayer or taxpayer funds or funds of your organization. And then there's a program administrator, which, is typically a utility or state or local agency or perhaps a third-party contractor, a nonprofit or a for-profit company, are responsible for achieving the overall design, the management, implementation of the program. Then there's the program implementer, and this might be the same as the administrator, but this might be a third-party contractor or a specialized firm that, is working with the program administrator, or as I mentioned, could be the program administrator, responsible for more of the day-to-day execution and the actual implementation of the DER measures. And of course, there's the participants, and this can include your trade allies who are working with you. There's an evaluator, which is that independent third party, potentially independent, or perhaps an internal team responsible for assessing the effectiveness, the impact, and the cost effectiveness of the program. And again, I'll talk a little bit more about that in the next segment. So overall responsibility, establishing the clear policy frameworks, facilitating the stakeholder collaboration and reviewing, oh, excuse me, and approving the program proposals. This is that monitoring and oversight responsibility. So, in summary, as I keep coughing here, your program design is really crucial for modernizing the grid. It empowers the consumers as well, and it can, achieve those reliability and affordability goals. But it requires a deep understanding of your market, the market barriers, and the mechanisms, and the continuous adaptation that might be necessary. So I encourage you to look at your objectives and goals. Look at the cost effectiveness and the value proposition for everybody who's participating, and in the implementation, identify those rules, identify the risk, and incorporate evaluations to have that feedback. So with that, why don't we see where we are with any questions that have come in? Miles, is there some in there that we should start thinking about responding to? I'm going to stop sharing.
Yeah, Steve, we have comments from your chat box question. I don't see any questions yet. If anyone would like to put one in the chat or raise their hand and ask Steve a question, feel free to do that now.
I know I went through a lot. And Miles, were you able to put the link for the presentations into the chat box there?
I did. Yep. The link is there in the chat box. I'll repost it later on as well. But had some good feedback from your chat box question after that.
Okay, good. Good. Well, feel free again, folks, to be too shy in terms of asking questions or providing any feedback. But we can also look to dig
I have
in.
a question, if you don't mind. This is
Please.
Michael Lozorchak from the Town of Stowe Electric Department.
Hi.
I'm curious, we have a DER program and we just rolled it out a couple months ago. And I'm wondering if you have any clear advice or lessons learned or other successful programs with respect to explaining the benefits of the program to the customer, because these are complicated issues. It's difficult for even the utility to speak internally about it. And I feel like the way we are trying to explain the benefits of the program it's just a little difficult for folks to understand and see the value of it.
And is it for residential customers?
It's for residential customers, yes.
Yeah. Yeah, well, first of all, don't feel alone. It is difficult to explain this to folks. I guess, and I don't want to necessarily promote one particular, program design or contractor, but there's a company called Ohm Connect, OHM Connect, one word, and they've been running residential demand response programs for quite a few years. And so perhaps just looking at their website and how they induce people to sign up for their programs, you might see some materials there that might be helpful for that. But certainly keeping it really simple, and giving people examples, that don't necessarily explain, the nuances of the grid, but say, if you turn back your thermostat or, reduce your load in various ways, we can provide you an incentive and it helps the system. I don't know, Miles, do you have any suggestions?
I mean, from my experience, typically have like a few different market segments. And so some utilities may have invested in determining who is in what segment and or just that there are segments generally. And so you'll see sometimes that messaging is catered to. There might be a more green messaging, there might be more financial based messaging. And so I think there's, to the extent there's any information on who all is out there and just that there's, diversity among motivations for joining a program, I think being able to cater specific messages is can be useful as well.
I don't know if there's others, here who are doing some programs who have some thoughts about what they've been doing. Michael,
Steve,
too, it's something too, your contact information is included with the slides here. And, um, perhaps if you want to send us an email, we can see if we have some more examples of marketing materials and such that maybe do a little digging and find for you. So please let us know.
Well, thank you.
All right. Well, with that, why don't see if I can pull up our next presentation. I'm going to do a little better job of pulling these up this time. Okay. Okay, Miles, we seen that one okay?
yep, we are good.
All right, so now we talked a bit about designing programs and putting them together. Now we're going to talk a little bit about evaluating distributed energy resource programs. So I'm going to start this off with a little bit of context and definitions. And again, I'm going to talk for about, 20, 30 minutes here about evaluation. Unfortunately, this will not necessarily make you experts ready to go out and run an evaluation, but it hopefully, again, provides you some concepts and ideas that if you're doing evaluations, give you some more thoughts to think about, maybe new things to include in your work. And if you're getting going or just starting to think about this, have some good thoughts and questions to ask and some outlines to use as you put together, your overall programs, including an evaluation aspect to it. So I usually start these off with this slide here, talking about, what we're trying to achieve, with these DER programs. And it's sort of following up from that last presentation. It's, really accelerating the adoption of DERs, feeding continuum of actions that might start with, research or demonstration programs, going out to the implementation, the deployment, the voluntary, actions to get people to apply more DERs in their facilities, and then get to that potentially transform markets. And the evaluation is an important tool to support these actions. It's that feedback loop. So that gets to, why would we evaluate? So the idea here is to document the impacts. First of all, and that's I think what most people think about when they're looking at evaluation, basically provide that proof of the effectiveness and the responsible use of the DER investments. But there are other reasons to do evaluations. Uh, Two of them that I list here are to support the resource planning. So if you provide the data based on the performance of the programs that supports the future energy infrastructure investments. So you know what these DER investments are actually achieving. It supports your resource planning going forward. And then the one that I, in some ways, like to talk about the most, which is understanding why these effects are occurring. Identify ways to improve your current as well as future programs. And it gets to these sayings that are put out in management books quite often is, you can't manage what you don't measure, and things that are measured tend to improve. So it's really the feedback loop. So these are why we're going about doing the evaluation. However, the evaluation, is not all the same for all programs, for all entities, for all, jurisdictions. The evaluation perspectives and thus the scope of the evaluations do vary. And they vary based on the objectives and, of course, the resources, and again, that perspectives of the people involved. So you might have a specific program in regulatory context that has lots of performance mandates or financial performance incentives or not. You might be interested in just doing this one-time program, or you might be interested in really scaling it up going forward. When are the evaluation results needed? And how will they be used? Excuse me, I apologize for this follow-up to my cold here. So I got two examples here with one state that has pretty limited goals for their DERs. There's no performance incentives. They're limited, interest in moving forward potentially. And so they might need just a minimal evaluation effort. On the other hand, state B there, has a long-term energy savings targets, and they have incentives for their administrators, and they're really looking for solid data on DERs that can require a more substantial evaluation. And so not all evaluations are the same. They depend on your perspectives and your interests. The evaluation types that exist for DERs are the impact evaluation, and that's the one, again, most of us think about, where you're quantifying the direct or indirect changes associated, with the program, to say determining the amount of energy or demand saved. There's also process evaluations, and that indicates how the program is working, how's it performing, how is its procedures going from the point of view of the consumers, the contractors, the administrators, etc., and basically identifies how the program designs can be improved. For the market assessments, this feeds particularly for the market transformation programs, but all for programs as well, is understanding where the market is, and those potential studies needed to identify what the opportunities are. And they are essentially going to be used to characterize the DER market and where are your barriers and what are your opportunities. And to be, if you do those market assessments before, during, and after, how you're changing the marketplace. And then, of course, the benefit cost analysis, to identify the costs, the benefits, and determine whether the program is cost effective either in the planning stage or as you implement it or afterwards to see if you made cost effective investments. So impact evaluation, process, market, and benefit cost analysis. Some definitions, and unfortunately within this industry, there isn't some lockstep, absolutely written in stone definitions, but these are probably the most common. In that, when I talk about evaluation, we're really looking at a program or really a portfolio program level analysis. Whereas measurement and verification, a term maybe you've heard before, sometimes monitoring of verification, and that involves the data collection, the monitoring, the analysis aimed at individual sites or projects. So evaluation, the program, measurement and verification, looking at individual projects or measure. And then there's EM and V, which is a sort of catch-all term that sort of encompasses both the program and the project impacts. And then I want to mention verification as well. And that's really just ensuring that the DERs have been properly implemented and can generate the predicted impacts. That can be done alone, separate from a full evaluation, say, of the energy savings, or it can be done as part of the EM and V process. When to evaluate. So as I got into a little bit in the last segment about planning, evaluation is integral really to this planning, implementation, and evaluation process. So, really the best practice is to produce evaluations within the cycle of you implementing them so that you have the information to provide feedback as well as soon after the program's over. If you get the results 3 years after the program's over, things have changed so much they tend not to be as valuable or not terribly valuable at all, actually. So you really want to do that evaluation in a timely manner. Again, providing feedback for the ongoing program, support the overall portfolio assessment, and then the support for planning of future cycles or changes as you might need to do. It also can be useful for informing future evaluations. You get the information back about how certain things are performing. You might need to spend less money going forward to do as detailed a work in evaluation. So planning, implementing, evaluating the programs, so what are these metrics that you might see and who does what in this? The planning of the programs, these are usually conducted by the program administrator or the regulator, the agency, the owner, usually with third-party consultants, but not always. And you end up with the projected savings, from your potential studies. Then there's the implementation of the programs. And those result in claim savings. Those claim savings typically prepared by the contractors or the implementers. And then lastly, you're evaluating programs to come up with the evaluated savings. Those can be, again, done by the implementation folks, but often are done by the utility or the program administrator, often with a third-party consultant, hired to go in there with an independent review. So projected, claimed, and evaluated savings. So with that little bit of background, what are some of the evaluation issues? So here we have my first and hopefully only transition chart, because I'm not very good at doing these, but we're going to put you forward a little graph here. So what we have here is this black line. It starts by showing the energy use over time, before a DER program is implemented. And then this little grayish zone here, this is the time in which it's implemented. Energy use continues to occur within the facility. And then, of course, you have the energy use after the DER implemented. And we want to figure out what the energy savings are or what the impact was for this. Unfortunately, we don't have that facility without the DER anymore. So we're going to have to do something, and that's that red line. That red line is what the energy use would have been at that facility without the DER project. So it's an estimate. And what we get here, now with our green arrow, is the energy savings. So what happens is that for savings for most DERs cannot be measured because we no longer have the facility without the DER. So we have to estimate the energy use, and that means that we're going to actually have estimated energy savings. So that's the first thing that comes up when we do these types of evaluations. We're primarily working with estimates, and our goal is to make those estimates as good as possible. So that leads us to really kind of two dominant EM&V issues. We're dealing with estimates. So the first question, how good is good enough? It's in some ways the fundamental issue associated with evaluation with EM&V is really about how certain do you need to be about the impacts? And is that certainty balanced against the amount of effort to attain the certainty and the value of the information? So what that means is your EM&V, like your program, should be cost effective, balancing, the cost versus the value of the information. How good is good enough? And then the second big one is as compared to what? So as compared to what, in some ways, the fundamental question of life is comparing, first of all, a baseline against which the DER actions are compared, like in that graph that I showed you. So you need to establish what would have occurred in the absence, using the fancy term, the counterfactual, what would have occurred in the absence of your program, of the projects. But also, you're looking at DERs and you're comparing them with other energy resource options. So it's not DERs or nothing, it's DERs or some other energy resources. And so you're not only comparing, to determine the benefit or the impacts associated with the individual project against what would have occurred at that, say, facility, but also comparing what occurs with the DERs versus other utility system investments. So if not DERs, there's going to be something else. So they have as compared to what? As compared to what other resource options, and that's what you also want to evaluate for. So that how good is good enough leads us to this cost, time, and quality triangle. The way contractors like to look at this is that the owner, the buyer of their services or products can define 2 out of 3 of these. You can define the quality or the cost, or the quality and the time, but you don't get to define all 3 of them at the same time. So as shown here, if you're going to go for, good and cheap, it's probably going to take you a while to get the results. Whereas if you're going to go for good and quick, it's going to be expensive. And if you want to do quick and cheap, well, you can do that, but it's probably going to result in lower quality. So whenever you're putting together your evaluation and looking to how good is good enough, a way to think about it is this little triangle here of cost, time, and quality. You get to control 2, hopefully 2, but you usually don't get to control 3. Now, turning to the metrics that you see with impact evaluations, there's the gross impacts and there's the net impacts. So the gross impacts are defined as those changes, usually in energy consumption, but can be changes in demand or other impacts interested in, that result directly from the program promoted actions taken by the participants in the program, really regardless of the influence that the program had on the action. So it's really looking at what occurred, irrespective of what caused that to occur, whether it was your program or not. Whereas the net impacts, that's looking at what was actually caused by your program. So it's the portion of the gross savings that are attributable to a particular program. Some EM&V methods provide gross impacts, others provide net impacts. And so for those that have a gross impact, sometimes you'll see in program evaluations a net to gross factor, a percentage that you apply to the gross impacts to try to estimate how much is actually due to the actual program itself. So just because you see a change in consumer behavior or an impact or a savings, the question becomes how much of that is truly due to the program, how much is attributable to that program. So with that, I have another chat box discussion item for you all. And that's to maybe, again, share with your colleagues and thinking about, how you look at your perspective, where do you put on the spectrum of importance of doing the evaluation, the impacts of DER programs, and, how would you think about balancing cost, timing, and quality? Comparing the various objectives that you might have, and the timing for those, and how you might be using your evaluation results. So, Miles, I would just want to encourage you to sort of maybe share some thoughts between your colleagues. So as you're doing that, I'm going to continue on here and talk a little bit about evaluation methods. So the primary ones that we look at for impact evaluations, which is mostly what I'm going to be talking about, impact evaluation, is what's called measurement and verification, the use of deemed savings, and the use of comparison groups. So measurement and verification involves some level of measurement, some level of energy measurements, typically using a utility revenue meter. And that might be applied to a sample of projects and then applying the result from those sample of projects to the whole program. Deemed savings means essentially deeming what the savings are. They're using historical performance data for similar projects in a similar application to estimate what the impacts are. And then you have just simply installation verification to show that it was actually installed, hopefully properly working. Comparison groups, this basically using analysis of energy consumption data, for program participants in a group, that's very similar, a comparison group, determine what the savings would have been, say, without the program. And there's two different approaches, and I'll talk a little bit about both of these using fancy terms of quasi-experimental and randomized control trials. So starting with this project-based measurement and verification. So M&V determines the gross impacts. As I mentioned, the definition, those are just what the impacts are, irrespective of the cause. And often, as I mentioned before, again, you use a utility meter, but you can also do, various sub-metering approaches that can be used. And with that M&V, something's measured. The energy consumed, the hours of operation, but also might involve some other default or stipulated values, such as the weather. So you do take the measurements during a hot day. You want to know what the savings would have been during a cold day. So you use some variables or some deemed factors, such as, say, the life of the measure, because you're only doing the measurement and verification for 1 month or 1 year, but the life is 20 years. You want to project what those savings are going forward. And doing calculations using those variables and the factors, as well as what you measured, to actually come up with your resultant impact. Then when you obtain the program savings, you might look at each individual project, so if it's a program with a limited number of large industrial commercial projects. But if you have a program that has many projects, many measures, and they're relatively uniform, you might select a representative sample and then apply the results of that monitoring and verification or measurement and verification for those projects to the entire population. So your basic equation is that your savings equal the baseline energy use, which you have with historical data, the reported energy use, and then any adjustments, say for weather, or perhaps a change in the building operation, which is quite a challenge can be for measurement and verification-based approaches. Now, the deemed savings method is also called stipulated savings values and unit energy savings, quite popular, particularly for efficiency measures. Um, and basically what you do is you develop a numerical value as a per unit energy or demand savings. For example, the kilowatt hour savings for a defined LED lamp type in a defined application. And, if you put this 7-watt LED into a classroom, the annual kilowatt hour savings will be compared to a standard light bulb would be such. And that would be based on analysis for really well-known and documented savings values, usually based on measurement and verification of prior, 7-watt LEDs put into classrooms. They also can be used for, deeming the lifetime of that light bulb, how much pollution is generated based on prior studies. As I mentioned, these are almost always just used for energy efficiency measures, and that preferred source, really you need to have a basis for those deemed savings values is the previous evaluations that involve those actual measurements. Again, it's always best to have a separate verification process. Even if you're deeming the savings, that there's verification that the quantity of units were actually installed properly. There's a handbook that we prepared at the Berkeley Lab on technical reference manuals, which is a compilation that many states and jurisdictions, utilities use to list their deemed savings values for common efficiency measures, and that's available online. Turning to comparison groups, most of us think of this associated with drug trials, where there's a group of folks who receive the treatment, the pill, and a group of folks that receive the placebo. They're a matched group, so they have similar characteristics, with the only difference being that one has a placebo and one has the actual drug. Same thing applies here. So you're basically comparing the outcome for a group that implements the DER, the pill, and the group that does not. They just have the placebo. They don't actually implement the DER. And basically, the primary purpose here is to isolate just the effects of DER. So you have all the other characteristics of the control group and the project group, the treatment group, as being the same. So essentially, it serves as a proxy for that counterfactual. And really, if you can do a control group, they're really considered the gold standard for determining impacts. Two types that I kind of referenced earlier before are the randomized control trials, and those are the best. This is where participants are randomly assigned to either treatment group or the control group, and it really minimizes the differences between the two groups. This is often difficult to achieve, so you have something called quasi-experimental designs, and that's where the control group is actually based not on this randomly assignment, but some pre-existing groups or natural occurrences, one neighborhood versus another neighborhood, or perhaps a group of people who implement the program this year, that's a treatment group, and the group that's implementing it next year is a control group for that first year treatment group. So properly completed randomized control trial and RCT is really, again, the most reliable way to determine those impacts. So if it is, why is it not always used? Well, that means that there's probably some consumers that would be eligible for a program but aren't participating because they're part of the control group. It can be quite hard to establish that control group, particularly when you're looking at unique measures, say for commercial, industrial, but also even for residential. Getting the data access to the control group members can be quite complicated. They're not participating in the program, might have issues in getting their data, their information. And the control group results directly in net impacts. And if some entities might just be interested in the gross impacts. Um, um, and other parties to the DR program just might like certainty associated with their programs. And the deemed savings method does provide certainty. Whether it's particularly accurate certainty or not can be a question. But it's certainly, when you use deemed savings, you'd certainly have certainty in terms of what your impacts will be because you're deeming the results and just verifying that the work was actually done. So applications of these various impact evaluation methods. Um, so with the simple, well-defined measures, measurement and verification can be done, particularly with that utility meter. Deemed savings would be quite common for this approach, for these types of measures with simple, well-defined measures. But with comparison groups, given their cost and effort, wouldn't be necessarily as common. The complex, unique DERs, as I was mentioning, the M and V would be the most common. Deemed savings wouldn't be used because they're complex and unique. There wouldn't be prior data. And because they're unique, there is very difficult to come up with a comparison group. Whereas we have a large number of relatively homogeneous DER measures, say, residential measures and new construction, the M and V and the deemed savings wouldn't be very common, but comparison groups would be. And I have some examples of these various types in this table as well. So now I want to turn to evaluation frameworks, ways in which you can help put together how you would do your evaluations. So the evaluation framework, the idea of this is to provide guidance on your objectives, the processes that you'll use, and the activities involved in every aspect, any aspect of the evaluation process. So it would lay out the principles associated with the evaluation, your objectives, your budgets, the schedule, reporting requirements, and most importantly, roles and responsibilities. Basically a functional document, somewhat obvious thing. Basically, it's the plan for your evaluation. And Berkeley Lab also has put together a guide on the M&V frameworks, links available when you have the slides on your computer. So I mentioned the importance of defining evaluation roles and responsibilities, really addressing who is responsible for the various evaluation activities. And there's no absolute way in which this is done. This is something that's determined by, that oversight responsibility as to, who is going to be checking the numbers to see what the evaluated savings are, say, versus the claimed or the projected savings that I defined earlier. So, is this something where you're going to look at a third party to come in? And what are the responsibilities of the evaluators, the implementers, in providing the information report? I mentioned independent and third party. What is your definitions of independence? What's your definition of third party? Who's actually going to select them and retain them? Who's paying their bills? And does that create some sort of conflict? The qualifications. And then I just want to make an allusion to process evaluations, which are defined earlier as looking at how the procedures and such are working. Those might be done by the evaluator or by the implementer themselves. And over on the blue box here, I have an ideal definition of a third party. One definition that's been used for, independence, is an organization that's external, and using the word independent in the definition, from the entity or the program being evaluated, and independent from that funding source of that program. Their primary role, perhaps only role, is to conduct an impartial and objective assessment of the impacts. So in summary here, evaluations really can serve multiple purposes. They document impacts, they support electricity planning, system planning, and they provide an understanding of why the observed effects occurred. They provide the feedback that helps you manage your existing programs and design future programs. There's impact evaluations, there's process evaluations, market evaluations to support the development of the program, and the benefit cost analysis, which after a break I'm going to get into a bit. And then there's many approaches to determining the impacts. There's the deemed savings, the measurement and verification, and the control groups, with the ideal being the control groups, but often difficult to implement for various program designs. Key challenges, the tough issues, determining the baselines, what would have occurred in the absence of the DER, and really deciding how good is good enough, balancing the value of the information with the cost of attaining those information and the timing of those results. That cost, timing, and quality triangle there. And then these evaluation frameworks, again, which LBL has a handbook that might be helpful for you, for establishing the jurisdiction's guidance for how you want to conduct those evaluation, the budgets, and who does what. So with that, why don't we maybe turn to any comments or questions that folks have? How are we doing on our chat questions, Miles?
Yeah, we have some.
Oh, no, you go ahead.
Nope, I was actually just I was looking at the chat, but you go right ahead with your question. Thanks.
Yeah, so I think that one of the key obstacles to performing a program evaluation effectively, especially if the gold standard is like an RCT, is you talked about it pretty extensively, but just how difficult it is to achieve all the conditions that would allow you to I guess like show that there's a demonstrable effect with like a DER. Then also the impartiality of the third party that's going to make that claim. And also like the data access too. I believe Luke Denon, who's a prior EIF, conducted like a cost benefit analysis, and it took him about 6 to 9 months to get the data that was at the scale that he needed in order to do that. And that's a pretty good chunk of time for a fellowship. So what are some tips that you might have for an EIF who is interested in performing something like to the rigor that one would expect from a program evaluation? How would we be able to, I guess like how would we justify it to coworkers, directors, especially when there are already a lot of programs that have pretty rigorous program requirements, and there's a belief that there's already really extensive data.
Yeah, I mean, you've raised a number of the barriers for doing those, the timing, that there's already, things that the implementers, the administrators are already, the work they're already doing. And, if they look at the evaluation as, just another burden of data information and which might be used to judge them. So, a couple thoughts, and Miles, you have other thoughts too, is after I ramble on for a second here, is, looking as you get into this is identifying what these, in this case, the barriers for the evaluation is the data access, and looking at like, hey, I've got 1 year, in my fellowship, I need to work from the data that's available. So working through, what information is available as a starting point, and determining what you can determine based on that available information. The for getting the data access is whether there's some existing protocols that already exist that can be utilized. The Berkeley Lab has had similar challenges in terms of getting information with a say from a utility that's the first time they've worked with, going through the utility and perhaps their regulator as well to get the information. But if someone's gone through that process before, it's already gotten the approvals, already has the mechanism in place, can that be applied? And if it's not, perhaps being realistic about the time frame that might be required to get that information, and therefore have to go through a different approach. Maybe focusing on an aspect where the data and the information is available, versus not necessarily getting to all the aspects that you might be interested in trying to get to. Those are two that I can think of right off the top of my head. Miles, I don't know if you have some other thoughts. Put you on the spot too here.
No, I mean, my experiences in the past has been with demand response evaluations, and you tend to see those conducted by by third parties who already have a lot of the infrastructure in place to be able to do them do them efficiently. So once a big burden is getting interval data from utilities for the folks who are in the program, and also a pool of customers who could function as a control group. And so Once you have all that data, if you don't already have code that's there to be able to kind of, put it through the code to clean the data into a batch of control groups and be able to efficiently get to what those impacts are. It's a lot of work. So, I think to the extent you can utilize groups that can do that or companies that can do that efficiently, it's certainly a benefit for that. Because yes, getting data takes a long time, but then, the actual analysis, it's much more efficient if you have folks doing it who that's their specialty and they do it over and over and over again.
Thank you.
Yeah, sorry, there's no magic pill there, speaking of pills, that I can do, but looking to the resources that are available, and sort of charting out what's required ahead of time and finding out what resources. I mentioned data. Miles, or is there a consultant or contractor, someone who has some of those tools available that you might have access to? Any others? We could also take a little bit of maybe take a 5-minute break here as well. Let people stand up and stretch if they like.
Yeah, Steve, should we take a 5-minute break then and come back at, what do we say? Let me convert my clock to Eastern time. 3:23.
3:23.
All right, sounds good. I'll put that in the chat. We'll see everyone in 5 minutes.
Okay, thank you. For our about a little more than an hour to go here. And let's talk about benefit cost analysis. So talk about program planning, talk about evaluation of those programs, and really as part of that is the benefit cost analysis of our DERs. So get into that a little bit here. So before I start talking about it though, I want to provide some acknowledgments that the material in this presentation is from a professional certification, some of the material, and it's about the National Standard Practice Manual, which is a guidance document that was developed in 2020 and goes through the practices associated with evaluating the benefits and costs associated with DERs. So it's certainly applicable to the presentation here. DOE and the Berkeley Lab supported this. And for disclosure, I'm actually one of the co-authors of this guidance document and the trainers for the certification course, which is why I have some of the presentation slides and sharing some of those again here with you today. So I wanted to give you some acknowledgments there where some of these materials are coming from. We'll have references for the NSPM and other documents as well in the presentation. So that NSPM, why I'm referring to that, it's really becoming the primary guidance resource for these benefit cost analysis in the US and actually a little bit in Canada as well. The slide here on the left shows some states that have either cited the NSPM or actually applying it in their benefit cost analysis. And there's a number of resources associated with it. There's the NSPM itself, the manual, and the current version, as I mentioned, is 2020. But there's actually a 2025 version that we're hoping to get out at the end of the year. We're revising that. And it's really built on the somewhat original work in this area from the California, called the California Standard Practice Manual. But that was last updated in 2001. And there's just been a lot of changes in our world for the last 24 years. So there's also some other resources. There's a methods, tools, and resources document, the MTR, and that provides some guidance on how actually to quantify the impacts, the values, the numbers that go into the impact analysis, the benefit cost analysis. There's a guidance document on distributional equity analysis for efficiency and other types of DERs. There's a database of screening practices, which a lot of people find very useful that gets into what different jurisdictions, usually state public utility commissions, are including in their benefit cost analyses of DERs, which impacts they're including, which costs, which benefits. And then there's some case studies as well. So these are all clickable links in the presentation that Miles has put up on the website and provided you the links with. So quick definitions, somewhat obvious here. Benefit cost analysis is basically an approach for assessing the cost effectiveness of investments, by comparing the benefits and the cost of options. There's one option, without the proposed investment, the best baseline or the reference case, and then with the proposed investment, the DER case or cases. And you want to do that analysis over the life of the proposed investment. So once again, as compared to what, I talked probably too much about that back in the evaluation, but it's also a fundamental question of the benefit cost analyses that you're comparing one option with another option and what the benefits and cost of those are. So with that test, usually a single indicator that compares the cost and the benefits. Two classic ways it's presented is a ratio, the benefits over the cost. So you have, benefit cost ratio of 1.2, the benefits are 20% higher than the cost, or a net present value using a discount rate, come up with the net value over a period of time. I'm going to be talking about benefit cost analysis and coming up with a specific test. But there is another approach for looking at analysis of the benefits and cost. Probably most of you are familiar, at least with the term integrated resource planning, IRP, or dynamic system planning, DSP. And basically that involves dynamically optimizing through simulation models, the cost to performance, other applicable attributes of all the resource options being considered, and putting them into optimization models, doing scenario analysis, sensitivity analysis, and basically doing a significant data collection and analysis effort with computer modeling. And involves in integrating analysis to look at that. It's a sophisticated model which is becoming more and more common. In the benefit cost analysis test in the IRP practices do have some common and unique attributes why they're both used. Both focus on the long term, both use similar inputs. The IRPs tend to focus on generation options. That's what most of them are used for, and do allow for some quite sophisticated analysis that's not always used in the benefit cost analysis test. And really the big difference is the benefit cost analysis test that I'll be talking about use a fixed avoided cost assumptions for energy and capacity. Whereas in the IRPs, those will float as they look at different analyses. So really with the benefit analysis, BCA test allow you to do really tends to be more granular analysis of specific programs and program designs and specific types of DERs because of fixing that avoided cost assumptions, something that's not necessarily available in doing the full IRP analyses. But I do want to make sure you're aware that there is another approach for this. But we're going to talk about benefit cost analysis. And first of all, these reflect a perspective. You have to have a way in which you're looking at the benefits and cost. And that way which you value them can vary depending on what your perspective are. Depending on that perspective, say, of the program participant, the energy consumer, that could be a different perspective than the utility. It can be a different perspective than the investor, the contractor, the manufacturer of the DERs. Certainly can be a different perspective from society as a whole versus the individual, and can be a different perspective for the regulator, the entity that's responsible for in the oversight of these actions. So let's talk about the regulatory perspective, because I think that's what many of you are coming from. And I don't just mean a public utilities commissioner. What I'm talking about is those that oversee the resource investment choices. And so there can be a wide range of entities that can be the regulator who have that responsibility for overseeing the resource investments. They're guided by various policies, regulations that they're there to follow and enforce. And so that regulator can be the governor or the legislature. It can be the Utilities Commission, It can be the utility, the co-op board, it can be your tribe, it can be a regional grid operator, it could be the federal government. But this is a perspective that's driving these utility investments, which is an important consideration when looking at your benefit cost analysis. It's a key perspective, the regulatory perspective. So the BCA test for that regulatory perspective um, is something that drives the National Standard Practice Manual, that NSPM. And so the NSPM sets forth various principles and guidance on how to build your own jurisdiction's benefit cost analysis test, or perhaps modify one that exists now. And it works to build that's right for your perspective, for your priorities, for your policies that exist, for your regulatory context. So this jurisdiction specific test, and since we got to have initials for everything, the JST answers the fundamental question of, will the cost of meeting the utility system needs while achieving applicable policy goals be reduced? And I'll be talking some more about the components of that definition. That JST is not necessarily just one test. It may include some secondary tests to help with assessing cost effectiveness. Um, and there may be other things that actually help you determine whether to make DER investment decisions. It might not just be the cost effectiveness as a decision maker. There can be other tests and other things that you look at to determine whether a DER investment is appropriate. It's not necessarily just the benefit cost analysis. And that's what this graphic here is trying to show. So we have the big bubble here, the big circle here is the benefit cost analysis. As I mentioned before, this is really looking at, comparing the cost and the benefits of a particular investment. Really what you're looking at is, will the cost go up or down, for consumers in particular, given a DER investment. But there are other things that can be looked at to complement that benefit cost analysis. Looking at the top left-hand bubble there, the rate and bill and impact analysis. This is something that can be a particular concern as to whether the rates, the costs per unit of energy are going to go up or down for all the customer participants, or perhaps all non-participants. So that can overlap in the analysis, but it can be another factor. Distributional equity analysis. Benefit cost analysis will tend to look at how benefits and costs are shared and applied and compared to each other on average across all participants or across all parts of a utility service district, for example. Whereas the distribution equity analysis looks at how the impacts, the cost and benefits will be allocated to different customer groups, rural versus urban consumers, big consumers versus small consumers, an underserved community relative to other utility consumers. That can also be of interest in making these decisions. And then economic development analysis. Will local economies, will they improve based on these DER investments? Will there be more jobs or less jobs? These are all potentially somewhat overlapping, but also potentially other important analyses that can be done to help you decide whether to make any investments. We're focused on these benefit cost analysis, but again, like with the RRP, I want to make sure that I don't, not let you, make sure that you don't come away from my presentation thinking this is the benefit cost analysis is the only decision that regulators use to determine to make that decision. So I'm going to get into about building your own JST, your own jurisdiction specific test. But before we get into that, I want to just sort of come back to that California Standard Practice Manual from 2001, because many of you are going to be hearing these terms or have heard these terms for the standard tests that are in the California Standard Practice Manual. There's the utility cost test, which looks at from the perspective of the utility system. Will the utility system costs be reduced? There's something called the TRC, a common test that a number of states apply, although they all tend to define it differently, the total resource cost test. And that's looking at the perspective from the utility system plus the participating customers. And so will the utility system and the program participant costs be reduced? Societal, obviously looking at society as a whole, so you have a societal test. The participant costs, looking at just from the perspective of the consumers who are participating in a program, will their costs be reduced or increased? And then another test that gets to that rate impact, the rate impact or RIM test, looks at the impacts on rates paid by all consumers, all customers of the utility. So these are standard tests that I want to at least provide you with a slide of their definition if you hear these terms. But we're going to be talking about the jurisdiction-specific test. So the first step involved here is looking at the NSPM's principles. There's eight, well, I should know this. There are 8 principles established by the NSPM that are the basis for developing the test. First of all, the DER should be compared with other resources and treated consistently. So you consistently look at all the resources. You need to align those cost effectiveness tests with your applicable policy goals. Each of these I'll get into a little more. You want to ensure symmetry. If you include a cost, you want to include the equivalent, the related benefit. Related, and of course, if you include a benefit, you want to include the related cost associated with that. Most importantly, you want to account for the relevant material impacts, the ones that have a meaning and have a material impact on the results, even if they're hard to quantify. And this can be a difficult thing for many people because some of these impacts can be difficult to quantify. We'll talk about how you might be able to address those even if you can't quantify them. You want to be looking forward. You want to look at long-term analysis to cover the period of time that the DER will be in place. You want to be looking forward to, no analysis of sunk cost in the benefit cost analysis. You want to avoid double counting through clearly defining impacts. And a number of the impacts associated with benefit cost analysis, can have some overlaps with other ones. So you want to make sure there's no double counting. And then just good practices, ensuring transparency and presenting the results on the analysis. And then this 8th one here was included to indicate that the rate impact analysis is actually something different than the benefit cost analysis, and that they answer different questions, as I referenced before, looking at rate impacts on how rates are impacted, whereas benefit cost analysis obviously compares benefits and cost overall. As I mentioned, I'm one of the co-authors, and we're looking at, as we're rewriting or revising the NSPM for the 2025 version. So we're thinking about broadening that last principle to make it more about decision-making involving complementary analysis, which can include the rate impact analysis, but also the distributional equity analysis, as well as looking at the economic and jobs impact analysis. So those are referencing that those additional impacts can affect the decisions as well as the rate impacts. So, I have one more of my little flowing slides here. So here we go. So, real important thing about the NSPM. It does not say this is the test to use. It doesn't recommend any specific test or policies or impacts to be included. What it does is it supports practices that align with your policies and your goals and objectives and provides a process by which you can build your own jurisdiction-specific test, your own JST. So what that involves is these principles that I just went through, and that means that different principles can these principles take into account the resources and the policies in your jurisdiction. So that means that different jurisdictions can have different JSTs. So you have a primary test that comes out of this, and the question it answers is which resources have benefits that exceed the costs and therefore merit the potential acquisition or support. You also might end up with secondary tests that can be used to provide additional information. And those can represent different perspectives and answer different questions that, again, help you make the investment decision. So one more of these, we have a framework that's defined within an NSPM, 2 phases presented here, applying those BCA principles, which I've mentioned, and then using a multi-step process, which I get to in the next slide, to develop the primary test. Also identify any parameters that go with the test, such as what discount rates to use. And then as part of that, develop secondary test as necessary, but the primary item here is your primary BCA test. And then the second phase, identify the methodologies for how to estimate the impacts. So you don't start with, identifying how am I going to come up with the numbers. You first come up with which impacts do I need to include in my test. And then once you've done that, you can also identify these complementary analysis, as I mentioned, say, for example, the rate and bill impacts or the economic job impacts. And then the third phase that would come up was actually doing the analyses and interpreting the results and making your decisions on your resource investments as supported by both the BCA analysis, but also potentially the complementary analysis. So applying the principles, figure out what's in your test, identify the ways in which you're going to come up with the values to come up with the actual numbers to include in your test, implement it, and make your decisions. I mentioned a multi-step process to develop the test, this JST. First step is really articulate your policy goals related to this. Next slide or so, I'll talk a little bit about that. You want to include all your utility system impacts. What we're talking about here is something that addresses the utility system, usually funded in some way by utility system funds, ratepayer funds. So you're going to include all those utility system impacts, but the non-utility system impacts, primarily host customer impacts, perhaps low income customer impacts, other fuel impacts that are not regulated, and societal impacts that you might be of interest. Those are determined by your policies, what your regulations, policies indicate are appropriate to consider when looking at these types of investments. And then that step 4 is ensuring that they're properly addressing, going through those principles, such as symmetric inclusion of benefits and cost, including all the relevant material impacts, making sure you're not double counting. And then the 5th step is, the comprehensive transparent documentation, which would hopefully be part of any analyses that you're doing. So some other considerations for establishing these benefit cost analysis tests. I've got 6 of them listed here. I got the first 3 here. I'm going to talk a little bit right now, and then the last 3, secondary tests, discount rates, and assessment levels. I have a slide each on those. So sensitivity analysis, hopefully something pretty obvious, is, it's really hard to predict the future values and cost and such. And so you might not want to do just one number for every cost and benefit, but to do sensitivity analysis as part of your work in doing the benefit cost analysis. So you can put those error bars around the cost and benefits over your BCA test. It's a benefit cost ratio of 1.3, and based on your sensitivity analysis, your plus or minus 20% or whatever you think is appropriate. Updating the test and impact values, cost and benefits change over time, and the policies that determine what impacts to consider, particularly say societal impacts to consider, do change over time. So a test that's established in 1 year might not be appropriate several years later. Geographic boundaries. So when determining your impacts and the values for your impacts, how large an area you're considering. Is it just, say, the utility system jurisdiction that you're interested in? Is it state boundary? Is it nationally? Is it globally? This tends to be most important when looking at economic impacts, job impacts. You might be increasing local jobs in your communities, but statewide it might have a negative job impact on other aspects of the industry, and in terms of vice versa, of course. And then for environmental impacts, pollution, air pollution that goes across different boundaries is not necessarily considered. So if you're coming up with the value and cost associated with pollution, one consideration is whether you're looking at that impact just within the neighborhoods, or whether you're looking at downstream, so to speak, impacts as well. Secondary test, I've referenced those before, that the primary benefit cost analysis test is your kind of go-to reference to inform your investment decisions. But those secondary tests can include categories of impacts that have been excluded from the primary test, or vice versa. You might want to have some categories included that you have in your primary test, which you want to exclude from the secondary test. So why you might have those, some secondary tests, to support marginally effective, cost-effective DERs, let's say your JST, your primary test, is really close to one. You may be under a secondary test that provides some more information that it's really good under the secondary test, might, make a decision to go forward anyways, or maybe it's really poor under the secondary test and supports the decision not to go forward. And then secondary tests can also help inform how much to invest in the DERs. Determining which DERs merit investment is really a different question than how much to invest. And sometimes secondary tests can be beneficial for that. Discount rates. I suspect most of you are familiar with the impacts associated with discount rates, but in a benefit cost analysis, you're going to be looking at the cost and benefits over a period of time. So you're going to be using discount rates. And basically, the higher the discount rate, the lower the value of future benefits and cost. This is what this graphic tries to show here, is that if have a $10, something that's $10 in the first year, if you don't discount it, it's worth $10 in the 20 years. But if you discount it, especially if you discount it a lot, the value goes down. So it tends to give you, it tends to give you a longer, it tends to value a longer term investments and takes into consideration longer term cost if you have lower discount rates. And there's a range of ways in which you can look at determining which one. The NSPM, for example, does provide some guidance on that. Then the assessment level approaches. So when you're screening basically out an investment, whether screen it in or screen it out, you can look at the DERs at, say, the entire portfolio might include a wide range of DERs, as well as a wide range of, say, customer types. You might want to just look at the sector level, whether, say, the commercial programs, residential programs in total are cost effective or are not cost effective. Again, at the program level, you might have 7 programs and you look at each program's cost effectiveness. You could even look at the individual project at a measure level in terms of assessing the cost effectiveness. And so your really key question here is, at what level does it need to be cost effective? Do you need every measure, every project, every program cost effective? Or are you satisfied if at the sector or the portfolio level? Not always, but fairly typically, screening is done at those higher levels of the program or the sector or even at the portfolio. I've talked a lot about impacts, but I haven't really given you any examples. This slide here and the next one give you some examples of various impacts that will be included in benefit cost analyses. This slide here, which has lots of rows and numbers and information in it, is one for utility system, actually electric utility system impacts, generation, transmission, distribution, general. Because utility system is involved in DERs, the NSPM recommends that whichever ones are material and relevant should be included in your benefit cost analysis. This color coding is associated with different DER types: efficiency, demand response, distributed generation, storage, and electrification, whether they're typically a cost or a benefit. Green benefits, red cost for the DERs, different DERs, and the different impacts. There's some orange dots because sometimes it's not always clear in terms of whether the DER is providing a cost or a benefit. I'll just pull one example here. We have risk and reliability associated with distributed generation is shown as an orange dot, can be a cost or benefit. Really depends on whether the distributed generation that's being implemented is more or less risky and reliable than the existing system that's displacing. Excuse me. So with this next slide, I'm showing some host customer and societal impacts. let you peruse that for a second while I take my drink of water. So again, these are some typical ones. These are all described in NASPM, and they're all, again, whether you're going to include this or not is dependent on your jurisdiction policies, whether your policies, regulations, your guidance indicates whether reliability or resilience for the host customer, for example, is an important aspect. If it is an important aspect, if something is associated with the goals and the expectations of your program investments, then it should be included in the cost benefit analysis. Same thing on societal, depending on the interest that's driven by your policies, in terms of whether it's resilience or public health, energy security, environmental considerations, determines whether you should be including those in your benefit cost analysis. So with that, we thought another chat box discussion that you all might want to participate in is thinking about what are the policies in your jurisdiction to define which impacts to include in a DER analysis, benefit cost analysis. What are some of the host customer and societal impacts to be included, based on those policies that you have. And so again, I sort of list some of these here, and you can look at this for a minute here and see, which ones that you think, might be of interest. Excuse me. So as you go through that, and maybe do a little bit of chatting in the chat box there, let me continue on to the topic of determining the values. This subject itself can be a 2-day class on how to come up with the values for impacts to include. But let me just say that there is a reference out there, that methods, tools, and resources document. And just mention that the magnitude of those impacts clearly can vary across different DERs and different applications, depending on the technology, the use case, the operating profile, who owns it, can determine what the cost and benefits are for different parties, location, what time of day, of course, for demand response, is it behind the meter, front of the meter, interactive effects between different DERs, something to be taken into consideration, and whether in your analyses, for example, something as basic as to whether you're using average versus marginal values. Some approaches for developing these numerical values. There's coming up with your own studies, your jurisdiction-specific studies. It's probably the best approach, but can be obviously expensive and time-consuming. Another is to apply studies from other jurisdictions. It's often, but not always, reasonable to extrapolate results from other studies when the local ones aren't available. Using a proxy. If there's no relevant studies of monetized values, a proxy can be used. And again, if it's relevant and material, if you just use 0, if you don't come up with a value for it, you are in effect giving it a value. You're saying it has 0 value. So if you can, just chokes me up thinking about it. So if you have difficulty coming up with values, it's better to use a proxy or potentially an alternative threshold. So in summary for these, I'm going to let you read these, and so I don't continue to cough as I do the presentation. And then we can turn to see if there's some questions. Excuse me.
And
So,
I'll just plug the links that Steve has in his presentation for the NSPM and the resources from the NESP. Those links are in the slides, and they're ones that that I refer to quite often for the work that I'm doing as well. So they're really helpful resources.
yeah, thank you, Miles. How are we doing? Any questions? I know we're getting close to the top of the hour here.
Steve, I have one for you. How about you had the slide on discount rates. How do folks conducting BCAs typically determine what the discount rates would be?
So we do have a long appendix in the NSPM that goes into that. So I want to provide that as a reference if people want to look that up. The two of the principles you can look at are, again, what are the policies? What are the established within your jurisdiction that are appropriate in terms of looking at their perspectives. The two of the common um, discount rates that are used is the WACC, the weighted average cost of capital for the utility, and the other is a societal discount rate. Those can be significantly different. Say a WACC at the weighted average cost of capital at say 8%, whereas a societal discount rate might be more closer to 2%. And one of the so I mentioned that because one of the other factors that can be used in deciding which discount rate is who are the costs and the benefits going to, who are associated with those costs and benefits that you're including. So if your primary objective, for example, is for doing the program is associated with society, that's a primary driver per your policies for while you're doing this, the societal benefits, perhaps a societal discount rate. But if it's all about utility investment and it's primarily utility system investment dollars that are coming from the utility, then perhaps the WACC, their weighted average cost of capital. So looking at your policies that you have for what's driving these investments, but also who's doing the money, who's doing the investing, and who's doing the benefits, their discount rates.
Great, thanks. Given that we're almost at the top of the hour, I'll move on and I'll take it the last half hour with my presentation. But Steve, thanks so much for all of those three presentations. It's a real wealth of information, and so again, those slides are linked on the website. And thanks very much. I'm going to share my screen here. All right. Thanks, everyone. It's good to be speaking with everybody again. I will be walking through an application of benefit cost analysis to managed electric vehicle charging. I'll cover first some background of what is managed EV charging. We'll look at some types of programs and rates, enabling equipment for metering and control. And then we'll get into the specific steps of benefit cost analysis, or BCA, for managed EV charging. So we'll walk through those steps and we'll focus on what some of those considerations are if you're looking at managed EV charging specifically. And throughout the presentation, there are some points where I bring in findings from a forthcoming report that we have on it's a best practices guide for BCA of managed EV charging. And then at the end of the presentation, I'll cover some of the specific findings from that study. All right. So first, some background. So what is managed EV charging? It's optimizing EV charging to reduce peak demand and respond to local and system-wide grid conditions. This can be done through program incentives and time-varying pricing. So pricing that depends on the time of day. And the idea is that you're still filling the car, the EV battery, so your energy consumption is the same, but the time frame or that load profile for charging it is different, and so this can lower your energy costs for customers by reducing consumption on peak. If you have a vehicle to grid program, you can also discharge on peak. In some cases, you can defer or avoid capacity upgrades, and this is for generation, transmission, and distribution. And then you can take advantage of lower cost energy resources. So the couple concepts here that come to play. One is this, the system-wide grid conditions. So there's system peaks. That's when you're looking at all your customers together for the utility system and determining when that peak, when your peak is throughout the day. That's also called the coincident peak, and that tends to be when energy is most expensive. On the other end, there's non-coincident peak. So this is where you would take a subgroup of customers and look at where their peaks are specifically. So, every individual peaks at a certain time of day for their own use. For this application for managed EV charging, it's useful to think about, distribution circuits. So where and when would a particular distribution circuit peak, whether or not that is in line with where the overall system peaks. So this graphic here at the bottom shows the load profile from, on the left, everyone charging as soon as they plug in, versus on the right, managing the charging to fill the EV batteries, but avoiding 250 kW of non-coincident peak demand. So this table shows the different types of programs and rates for managing EV charging. And it's broken down into a few categories there on the left. Active programs, this is direct load control. So this covers, you plug the vehicle in and there's an actual, on-off or continual managing of the charge. So the first subcategory there is event-based. And this is similar to a traditional demand response program. There's an event. During the event, charging is adjusted or ceased, and then resumes at the end of the event. There's continuous. So this is also known as dynamic managed charging, and this looks at what the real-time situation is on the grid and then adjusts based on a particular algorithm that could include both those system level conditions, the retail price of electricity, and distribution circuit issues, so those non-coincident peaks. And then bidirectional charging. So this is, you hear this referred to as vehicle to grid, V to G. There's V to X, so it's where the vehicle is discharging into either the grid, a building, another vehicle, some other load. On the passive program side, we have, these are behavior-based. So you're incentivizing customers to charge at particular times of day, based on the incentive that you provide them. So there's no direct control. The last category there is rates. So sometimes some categorizations refer to rates and these passive programs as passive managed charging. Here we make that breakout there. So we look at the different types of rates that can be used for managing charging. Whole premise time varying rate, or TVR. So this is like, think of a residential time of use rate where the entire home has a time of use rate, and so there is an incentive there not to charge at those peak times if you have an electric vehicle. There's beneficial electrification rates where it's still applied to the entire premise, but the difference between the peak price and the off-peak price might be greater since it's being targeted at those customers that have electric vehicles. So for instance, like Southern California Edison now has an EV rate that you can opt into as a residential customer, but you have to show that you have an EV, but it still applies to your entire home. Then there's these EV only rates where the rate is for EV charging only. So you have a separate meter measuring that EV charging. And then demand charges, there's the last one. And these are, Steve touched on these in his presentation. So, as he mentioned, they're typically used for the commercial customers. But we're, starting to see more utilities experiment with them on the residential side as well. And here we look at what the enabling equipment for managed EV charging metering control is. And so this can come into play when you're conducting a benefit cost analysis or designing your program. The most common is measuring the whole home or the whole facility consumption via a single account meter there up on the left. That second configuration, so that one in the middle, is installation of a secondary utility meter dedicated to measuring EV charging. And then third one would be relying on measuring that charging load either via sub-meter embedded in the electric vehicle supply equipment or the EVSE, or vehicle telematics data, so measuring it through the vehicle. And then on the control side, again, you have control that occurs through that EVSE or through the vehicle. So yeah, and the equipment costs that you include in the BCA could, vary significantly depending on how you decide to measure the electricity consumption for the program, based on these examples, and whether utility already has fully deployed their advanced metering infrastructure or AMI network. Okay, so poll question. Let me navigate and activate this poll. Sorry, it's not letting me launch this poll for whatever reason this is. But let me try one more thing here. If it doesn't work, we'll just skip it. But no, no go. Sorry, everybody. But anyway, the poll is, I was curious how many of you all have time of use rates available from your utility, and are you on one? So that, the different options that you see right now tend to be that you have a time of use rate available, and you're on it, whether you're defaulted in or whether you opt in. You can have residential TOU available and opt out of it, or just choose not to opt in. And then you may not even have it available. So you might have like an inverted block rate or some other type of rate, given that it's not an option. All right, so next topic here is we'll get into the actual steps for conducting a benefit cost analysis for managed EV charging. We have here, this is, I broke this process up into 8 general steps, and we'll walk through what these are. And we'll focus on, again, the considerations for managed EV charging. So first step is to specify a set of alternatives to analyze. So as Steve mentioned, these alternatives are distinct courses of action where you could have an alternative being a program, a combination of programs. You could have a combination of programs and rates, but these are alternative courses for moving forward, where you also have one alternative being the business as usual case, or the status quo, or the counterfactual. So it represents the course of action if you don't follow any of the other alternatives, and you continue moving forward as usual. You're measuring all costs and benefits relative to that status quo for each alternative. You'll also want to determine the timeline of the analysis based on the set of alternatives that you choose. I'll note here, for looking at different design features, there's this blue box here on the right. So Steve covered some of these for DER. In general, we could look at EV managed charging. You would want to note whether you're looking at residential EVs, commercial fleet vehicles, charging stations, whether you're looking at an institutional program. So for schools or government facilities, you'd want to specify the type of vehicle. So is it light duty, medium duty? I put school buses on here as they've been a popular option for looking at vehicle to grid pilots, because they have a pretty predictable charging pattern and use pattern throughout the day. Program incentives, how are you gonna get customers into the program? Will you pay an annual amount, or you do more of a performance-based incentive? And then rate design. So what's your differentiation for different time periods? I will note here that for looking at rates, we don't generally see benefit cost analysis used as a decision tool for just looking at a rate specifically. And it's not to say that you can't, but BCA is more common as a decision tool for whether or not to, we tend to see rates analyzed more for benefit cost analysis when you're looking at whether or not to get AMI for the utility. So, time varying rates are enabled by AMI, and so it's one of the multiple benefit streams for that full investment. Next step is identifying the primary cost effectiveness tests and any secondary tests. So as Steve mentioned, there will often be specific tests that regulators have determined should be required, and which is the primary test. Best practice would be looking to use the same primary test that you're using for other DERs in the jurisdiction. And then, as Steve mentioned, also you would want to look at what additional secondary tests we would want to inform decision making. So utility cost test, will it lower the costs for the utility? On the participant side, is it worth it for the participant to enroll into your managed EV charging program? So looking at the different incentive structures that you have to offer versus maybe some of the equipment costs that they might have, to determine whether it's worth it for them in the end if they participate in the program. And then you can use the results of these other tests to help to modify what your maybe what your program incentives would be. Step 3 then is determining which utility system, host customer, and societal costs and benefits to include in the analysis. So you're not quantifying yet, you're just looking to see which impacts would be material and that you should consider when you do your consider moving forward in the analysis. So on the utility side, for managed EV charging, you would have your program administration, which would include, and I'll just give examples, but not comprehensive. But program admin, you'd be looking at your marketing. If you have labor costs, what are your customer incentives that you'll be paying to get customers to enroll? And then, is there any enabling technology? So do you need to invest in a distributed energy resource management system, which you would use for triggering events? Benefits could be, for the utility system, the avoided costs related to the system that Steve went through. So distribution, transmission, generation capacity. I won't get into detail on these, but these are the impacts that you would include in your test. On the host customer side, right? So are there equipment costs, and then on the benefits, would be the incentive payments from their perspective. If you're including the host customer benefits, again, you would want to include the host customer costs in your test. And then societal benefits. So are there emissions reductions because of the shift in the timing of your charging induced by the program? And this slide shows one of the findings from the study that we were doing on benefit cost analyses. This is looking out at 15 different BCAs for managed EV charging programs that we're able to find throughout the US. And this lists the different benefits and the costs that are present in the programs. So, I won't get into detail on each item here, but generally on the benefit side, you see the avoided capacity for distribution, generation, transmission, even energy generation as the key benefits that utilities are including in their BCAs. We'll see over on the right with the costs, again, there's program administration, which can include, it's not always consistent necessarily, but it includes the costs of administering the program. One note here is that there are several different perspectives that a utility BCA could consider, and this chart groups them together. So you see on the left, there's financial incentives to customers as a benefit to customers, and then on the right, you would see financial incentives to customers as a cost to the utility. So that's why they're in both categories there. Next step would be to forecast your program and rate enrollment level. So this is really, now that you have your benefit and cost categories, you're trying to scope out the program. So you're estimating, first of all, what's the EV adoption going to be in your service territory? It's been steadily climbing, but depending on what incentives are in place, and things can change year to year. So there tend to be there's organizations that will update broader EV adoption forecasts that can be used in a particular utility or a particular jurisdiction. And then apart from just EV adoption, estimating the participation level among owners and lessees for the programmer rate. So this is a tricky one, especially in a new area like managed EV charging. How many people are going to sign up for the program? There tends to be a lot of uncertainty around it, but coming up with an estimate, accounting for the attrition from the program over time, and then also trying to track the different subpopulations. So in particular, how many folks who might be on a time of use rate versus a non-time of use rate, trying to figure out those participation levels from those various subgroups that where between those groups you would have different behaviors that would impact program impacts. And then data sources, Steve had mentioned these as well, but is there a pilot program, a prior program, a similar program at a peer utility, or can you get that data from conducting surveys or panels? Next step then is determining values for the impacts, and this includes costs and benefits. So on the cost side, the real key thing is you're just looking at estimating the incremental costs that you wouldn't incur absent the program or rate. So, BCA is a decision tool. So should you spend this funding in order to implement a program where you would get these benefits? So you're looking at incentives, you're looking at program admin, you're looking at incremental enabling technologies, but you're not looking at costs that you've already incurred or sunk costs, right? You can't, implementing the program is not going to change those costs, and so it shouldn't be part of your decision-making process. And then that last bullet down there, just that, you have your large investments with the multiple benefit streams, such as an AMI business case. They're foundational for enabling managed charging, but they would tend to be their own benefit cost analysis, and you wouldn't go back and incorporate those AMI costs into a future-looking BCA for a time varying rate. And on the benefit side, the key purpose of a managed EV charging program is to shift what the load profiles are, and so the load impacts they mainly tend to stem from what that load shift is and reductions in load at certain times. So it's the difference between the load profile of the managed charging, so your average load profile with the program, and then what we call the baseline, which is the load profile in the absence of the program. The avoided distribution, transmission, energy generation, GHGs, these are all derived from these shifts, and looking at the difference between these curves. So determining how to estimate these is important. On the right there, we see what an unmanaged program or unmanaged program could look like for, this is a 48-hour period. They have like 53 EVs here, I believe. This is from a Friday to a Saturday, so you see a larger Friday peak and a Saturday peak. You see what that load profile looked like for a time of use scheduled customers. So you get rid of that system peak, perhaps like in the early to mid evening hours, but then you have a large secondary peak, which could cause issues for your distribution circuits. And then toward the bottom there, you have distribution optimization, where you can spread the charging out and reduce both the system peak and the distribution peak. So determining values, again, we're looking at here we're getting at how do you actually determine what the impacts are. Steve had mentioned that the best case scenarios you have, let's say, a randomized control trial from a prior program or pilot. That is rare to have in any situation, but in particular for managed EV charging, Next best case, maybe you have interval data. It's not an RCT, but you have some interval data where you can retrospectively develop a control group using the methods. I gave examples here, but you could have match control, where you match individual customers to a similar customer. Synthetic control, where you're blending your entire control group to create a similar load profile to your program customer. And then this within subjects analysis, which this is typically used when you have larger customers that you won't be able to find a match for. No data is available, let's say, from a prior year's pilot or program, which is the most common situation, but you could look at load profiles suggested by program vendors. You could look at, I listed 2 publicly available sources for developing those profiles here and estimating impacts. And then you could also leverage estimates from other programs at other utilities. Next step is monetizing those impacts. So without, and this could be each of these could be their own separate, very long presentation, but in looking at considerations and what we found from looking at BCAs throughout the US, on the distribution capacity side, what we saw was that utilities would typically use their average system marginal distribution costs and apply them to peak reductions resulting from the program. Ideally, you would want to use more location-specific avoided costs. So each distribution circuit has a separate avoided capacity costs, but it's difficult to get. Transmission capacity, the methodology depends on certain factors for the utility, like the presence of a wholesale electricity capacity market, or needing to allocate certain regional transmission costs. And then on the generation capacity side, you can get these from resource planning models, so from the same models they use for an IRP, and emerging best practices, this idea of derating benefits, where you don't know exactly when the system peak is going to be, and so accounting for that uncertainty. You should note any immaterial benefits, even though they're not getting quantified for the BCA. So ones that are small, just note them, but you don't have to. If they're small, don't not include them, but just mention what they are. And then on the discount rate side, Steve covered this, but you would want to apply the same discount rate for benefits as you are for costs. And there's an example of some analysis that SMUD used on the right there, which I will leave in the slides here, but I won't get into detail on in the interest of time. Sensitivity analysis. So this is where we're looking at the impact of our assumptions and uncertainties on that end result, right? So how does it impact benefits, costs, the net present value that we get, and then the benefit cost ratio. So we're looking at, what are those key sensitivities? What are those uncertainties? Which sensitivities, which factors impact the end result the most? And for the ones that you might be really uncertain about, like participation rates, let's say, what happens? What does that end result look like if we get great participation versus not so great participation? And this is a graph from the Brattle Group, who had done a sensitivity analysis for a program. You can see the way that they had laid it out was you have your base case there in pink in the middle with the net present value, and then they just show how the net present value changes depending on varying the different factors throughout different ranges. And then presenting results, again, you can have results at different assessment levels. So you could look at a program, a particular sector, or for a whole portfolio. That could be like a transportation electrification portfolio, or portfolio of demand response programs. You want to be as transparent as you can, explain the methodology and the assumptions, and then include your non-monetized impacts. So even if you can't put a number or a dollar amount to them, to be able to fully inform the analysis, you should have a section for those. And again, another example from the Brattle Group report for Baltimore Gas and Electric, just looking at here's your benefit costs ratio in different for different situations, and breaking up what that what that present value is for costs and benefits, and it just gives that extra level of transparency, so you can see how how big the different benefit streams are. And then finally, considerations for managed EV charging. This slide gets it. If you're going to want to measure the program success and use the results, particularly the impacts for future for benefit cost analyses, and continue moving the program forward, how do you implement the program or design the program in order to be able to enable that measurement and evaluation? So, let's say on the design considerations, how big do you need your treatment and control groups? Is there a way of implementing the program to be able to measure some of these impacts? So this A/B testing option, if you have your treatment group or your program participants, can you break them into two and maybe have your event for half of them, and then not do the event for the other half, and get a sense of basically you're using half that group as a control group. Selection bias, so understanding what conclusions you can make from conducting your measurement and evaluation. Are the participants in your program, do they represent what participants would look like going forward, or do you have to make considerations about maybe discounting some of those impacts because future participation might look different than current participants? And then this trade-off between achieving impacts, enabling M&E. This is just a point that if you do an A/B testing option and you're withholding some treatment, you might not be maximizing your benefits for that particular event, but you are enabling later measurement for the program. And then it's going to cover this next part briefly because we're almost at the bottom of the hour here. But these slides give some high-level findings from our study. This lists the different utilities where we were looking at the 15 managed charging programs that had a benefit cost analysis. And the high-level findings, I think that the big takeaway here is that it's a relatively new type of program, and there's definitely some good work being done in analyzing benefits and costs, but there's still a lot of room for improvement. So the programs we looked at, they're mainly event-based DR programs or off-peak incentives. The documentation is varies widely across the different programs. So there's no standardization about what is in program administration costs, and it doesn't always say with a lot of clarity. They don't always explain and say what their baseline is. And then the discussion of methods or the use of enabling technology is limited. So I think in the area of presenting results and walking through assumptions, there's a lot of improvement that could be made. And I'm going to skip the last two slides. We're at the bottom of the hour, and the theme is fairly similar here. These things are it's still early in managed EV charging is still a nascent program topic, and some of these items are difficult to quantify, and we see that out through some of these BCAs. We are right at like 4:30, but if there's any questions, I'm happy to take them now. All right, if anything comes up later, here is my contact information. Please feel free to send me an email. And appreciate everybody coming on today. Steve, thanks so much for your presentations.
Thank you, everybody.
Again, the registration link is for the next webinar. The data centers one is in the chat and on the slides. Hope to see everybody there. So thanks so much.
Thank you, everybody. Enjoy the rest of your day. Thanks, Miles.
Thanks, Steve.